overhead costs. Imagine well the assembly line. This is a good explanation. So where we're gonna see, okay, to make a shoe, how in which way the assembly line cost should be incurred in the shoe price, and this is a cost driver, and the assembly is a cost pool. Okay. Questions, clarifications, please put it in the chat or speak up. So when it's all clear for you, we can go to the next part, which is the main exercise of this chapter. No reaction. Everybody can hear me because I see really no reaction of all of you.
Yes, I hear you.
That's good.
Yes, let's start with exercises and then maybe we will have more questions.
Very good. Okay, that's a good spirit. Okay, so first of all, I would like to explain a little bit. Okay, we can see it. So when you have, so this is a little bit what that you can see what it means is a cost driver. And so you have in a Fiat 500 factory, you have a lot of departments. Can you give maybe some of the departments you have in a car factory where which are necessary and which are there? So what kind of activities you can say and what activities are done, which can be seen as overheads, but which are needed to make a car. Sales and distribution. Okay, I would like to wait this. Okay, sales and distribution once again. These kind of we are still in a manufacturing surrounding. And so we have indeed sales and distribution and marketing and whatever costs, but this is not inside the scope of cost calculation. Cost calculation is most of the time, and like also here, it ends when you deliver to goods. So also we're gonna check the overheads which are linked to the production or the delivery of the service. When we see, for instance, and of course, these costs are also interesting. It can be also good, but most of the time we will not do. Assembly department, that is a very good part. What kind of activities or department cost can we have more? That's okay. You can have type of cost or type support department cost, support departments, what kind of costs? There are other ideas.
Production?
Excuse me?
Production?
Production? Yeah, production is very, I think it should be much more, it should be much more, production is quite wide, huh? So
this place where they take components and put them together.
Yeah, the assembly line. So in the assembly, for sure, it's good. But in the assembly line, you have, maybe you can see in the assembly, you can have different, in this department, you have a different kind of cost. Can you imagine what kind of cost you have, which is not direct labor and not a part of the car as such? What kind of costs do you think you still have, for instance, in an assembly line of a Fiat 500? So what are the tasks, what are the activities done? And maybe that's electricity. Electricity is, but see it more as an activity. What is done to the car on the line, which is not related with direct labor and direct material? What is done more?
Check up?
Check out, yeah. So quality checks. And so there is in the car line, assembly line, there are many checks. Every step they check things. So this is a certain cost. This is a certain cost. You get to have probably equipment to check. You got to have people to check. You have processes to check. At the end, this quality check, total overhead costs, get to be incurred, get to be put it inside. So this is and then, okay, how we can take this as an example. You see on different points the quality check. What kind of cost drivers or what kind of unit you will use to make a logic relation with the quality costs. So, and this is most of the time a number. And so, how you should divide the overall quality costs over your cars.
Indirect labor hours.
Simple is, of course, the number of cars. But it can be that sometimes you can have a much more quality check to do for one or the other. And so here we get to find a good cost driver. Okay, I will go in the next slide to show a few examples to make it a little bit more clear. So imagine you are still in this factory and you see a lot of support department costs. You have, for instance, the setup costs. What is a setup cost? It's when you change a car and make something different. And you can then say, okay, I calculate just a number of setups. You get to do a production scheduling, and you get to schedule which car you make at what moment. You can say, okay, I call it, I'm gonna calculate it versus the number of production runs. For the inspection and quality cost, as we have just seen, it can be just a number of inspection. It's possible that for certain cars you need to do more inspections than for other cars. And it's also logic that you incur a higher level of these inspection and quality costs. Purchase cost, it can be done on the purchase orders, it can be done also on a number of value. Dispatch cost, so it's most of the time cost driver, the key to make the pro data has a link with the actual costs. When you do a quality cost or inspection, we're going to use the number of inspection. When it's a purchase cost, we're going to use the number of purchase orders. So this is most of the time in a close relation with the department costs, which are all together in the activity pool. Okay. Yeah, so also let's say hourly wage of the people who control the quality. This is indeed also a possibility, but we should try to find it back also to the product who consumes the activity. So this is the hourly wage will result in a cost, but it is the total cost, which can be 5 people at a certain wage for $10,000, for instance. But you get to see how you can bring together this cost and incur it via a ratio, which is a cost driver to the different products, which consume this. So you have like here again. So it's maybe from bottom down. So the product services consumes via the cost driver activities which leads to resources. So the overheads are the resources. The cost pool or is the activity, and you need a key to relate it to the product. We're going to make immediately an exercise. I think this is the most easy to understand. This is what we call the framework of the ABC. It has 5 steps, 5 very clear steps, and we're going to make the exercise step by step. Most of the time, the first 3 steps are quite obvious and are often also already in the given. So we will go here in the slides over a first exercise, and then we will do the second exercise together. in the Excel sheet. Okay, so imagine that you are. Wait a second. Imagine that you are in a factory where they make two products. You can see it like a car. They make two different types of Fiat 500, and you should find a system how to allocate the overheads into these two cars. Depending, and these cars have different requirements, and they need maybe more inspection. The one needs maybe 5 inspection points. The other needs maybe 20 inspection points. So the total pool, the activity cost pool, which is quality check, has to be divided in a different way. So what we're going to do first, in the first step, step number 1, everybody sees very well this slide, framework of ABC, 5 steps. This is the key slide for the exercise. Okay, so first of all, you get to recognize the major activities. So this is, of course, in a big factory. These are a lot of activities. What you do the assembling, you do the machining, the finishing, the packaging, the transporting, a lot of activities, like we've seen before. And every product consumes a part of it. So we're gonna say what are the activities in an organization. Afterwards, we're gonna determine the most appropriate cost driver. So this is what we see. We say what is the most interesting. So for a quality activity, it should be interesting that we say the number of inspections. That's the cost driver. What we're gonna do afterwards, this is an intermediate step. We're gonna put all these identical identical activity cost drivers into activity cost pools, because we can bring this together. And then the second step is to make the ratio, an activity cost driver rate, to bring the overall cost into your product, to use of each activity. So these are the 5 steps, sorry. So the 3 first one are most of the time in a given, then we go in the 4th step and in the 5th step. I will go immediately in an exercise to clarify it good to you. So here we have a company manufactures 2 products, P and Q. Imagine that there are 2 different cars using the same equipment and identical processes. You are in a manufacturing line and you have car P and car Q, and they go as follows. From car P, you produce 6,000 units. From Q, 11,000. The direct labor hours, so on this first product, you need to work 1 hour per unit. On the other one, it's more complex, 2 hours per unit. But it takes 3 machine hours, robots, whatever, and the second product needs 2 machine hours per unit. So this means, and this you should calculate yourself, the total machine hours are 3 times 6,000 or 2 times 11,000. When we say more, that the setups, so the changes to be done in the period, the period can be a day, a month, whatever, is 10 times 10 setups you gotta do. And then for the queue, you gotta do 30 setups. Afterwards, you know that you have 15 orders handled, and here you have 35 orders handled for queue. So this is the information you get, and it's important to make always the totals. Then we say there are 3 main activities. So here in the given, it's already clear what are the 3 main activities. So what are the cost pools, you can say. So there is a machining activity, there is a production setup activity, and there is an order handling activity. These activities have overhead costs. And the machine activity is 250,000 euros. The production setup is 30,000 and the order handling is 40,000. we immediately say, okay, maybe also in other exercises I ask you to do this yourself, but for machining activity, yeah, it's quite logic that you will use machine hours. Everything is depending also when I should not give this information, what you have in the given above. When I don't give you any information about machine hours, yeah, then you should apply another cost driver. When you are, of course, in in a real example, you have many more information. Now, in the exercises, we reduce the information to the minimum just to go behind the logic. And the idea is that you understand the process and the logic of the exercise. It's not the purpose to make a super complex exercise. Okay. So for the production setups, the cost driver, you have this information also, is the number of setups, and the orders handling is the number of orders. What you have also in the given for product P, and you have it also for product Q. This is the given. Have you any examples for this? So examples, questions. So we are already in step 1 and 2. The major activities is machining, is yeah. So machine activity, production setups, and order handling. That are the 3 major activities, and we have determined already the cost driver for each activity, and we know also the cost pool. So all the costs and the cost pools. This is this drawing to show again. So you should have this in mind, the right bottom image. So all the costs are already in the activity pool. So for the activity pool here, machining activity is 250,000, 30, 40. Okay, no questions? We go one step further. So then the question is, calculate the production overhead that we get to include in a unit of product P and a product Q using ABC approach, while we use these cost drivers. So at the end, what we get to say is that from this activity, from this cost pools of 250,000, 30,000, and 40,000, so it's in total 320,000 euro overheads, we get to, in a reasonable way, we get to say how many euros we will incur, we will add to product P, and how many euros we will add to product Q. And we will do this step by step for each activity using the cost driver. Okay, here we go. So like I said, okay, the first 3 steps is already more or less done. So how we determine the cost driver rate? So there is a cost driver and there is a cost driver rate. And this is again, it's like the ratio, like the key we used before. It's not a cost as such, it's a rate, it's a pro rata. And what's very important that you see here in the end of the table is it's euros per hour, euro per setup, euro per order. It's per something. It's a ratio or a rate. So the machine activity, we say it's 250,000 euro. The total volume, so we go back and we take always a total volume of machine hours is 40,000. Meaning that the overheads, 250,000 divided by 40,000 hours, it's 6.25 euro per hour. Meaning when you should use 10 hours to make product P, imagine, then the overhead allocation for this one product is 6.25 times 10, 62.5 euros. Okay, it's different, but just to explain. We do this as the same for the production setups, 30,000 divided by 40, and because the total number of setups for product P and Q are here. 10 plus 30 is 40. The same we do for the orders handled. 40,000 is the total cost. We have 50 orders, so it means 800 per order. Now we go one step further because we have calculated the cost driver rates, the ratios, and the keys. But now we're going to apply these keys. So we know for product P, there are 18,000 machine hours, 18,000. And the machine overhead in this activity pool got to be calculated with a cost rate at 6.25 euro per machine hour. So you do 18,000 times 6.25, it's 112,000. For the setups, like you can see in the given, for product P, there are 10 setups. So here you do 10 times the key, which was 750, 7,500. And for the order handling, it were 15. And we said that the rate, like here, was 800. So we do 15 times 800. We add all these overhead costs of 112,500, 7,500 and 12,000, which is under 32,000 in total. We know that we have produced of the product A 6,000 pieces. So in total, the overhead per unit is 22 euros. For the product Q, we do exactly the same. We do 20,000, 22,000 times 6.25. We do 30 setups in this case, times 750, 35 times 800. But it's important to see that when we make the full calculation, that of course, the 188 total overhead product P plus the 132, which is in total 320,000, is of course exactly the same as the initial overhead cost, which you see here in the cost pools, 250 plus 30 plus 40. And that's quite logic that you get to divide everything what is there. And we divide it on this way. Then you can see that the overhead cost is 17.09 for product Q. Okay, that's it. Questions on this exercise? Can we recheck step 2 and 3? Okay, no problem. So here we go. So step 2, okay, I will go from the start. So step 1 is major activities. So here in this exercise, the major activities are machining activity, production setup, and order handling. Of course, in a normal organization, you have many more, but for the sake of simplicity, we take only these 3. Okay, that's good. That's step number 1. Step number 2 is determine the most appropriate cost driver. So the cost driver is what we say, and this is already given here. Okay, maybe normally we leave it blanco and then you can choose it yourself, but it's logic that for a machining activity, you use machine hours. When it's a production setup, you use number of setups. what we will do, imagine that you have another activity. You have another activity that you will also evaluate with the same cost driver, which has the same cost driver. Then you can put it together. So maybe there is, I should say, machine maintenance, machine maintenance activity. This is also linked to machine hours. Then you can put it in the same cost pool. So this can go together, and that is a step 3. Here, step 3 is actually not done, so group identical cost driver into cost pools, because we have always only one cost pool with one cost driver. So when we have more cost pool activities with the same cost driver, we can put them together. Because you will calculate, and it will become maybe not 250,000, but maybe there is another 100,000 for machine maintenance, and then you put it together, and then you can say from these two activities who have the same cost driver, we can calculate one ratio. Okay, and then step 4 is the calculation of the ratio based on the ones who have the same cost driver. So always on one cost driver, you take the rate, and the rate you apply on the different points for the specific product. Okay, good. Okay, I suggest that I will open this here. Okay. Okay, you can go also, of course, in the exercises you have downloaded. So we are now in exercise 2A. 2A, and yeah, I suggest that you start working on it yourself first, and then we can control it together. Okay? So I will go over with you on the given. So here you have 4 different products. A factory produces 4 products. You have a lot of information here: the number of production runs, the number of setups, the output, the labor hours you need for units. For making this article, you need 1 hour. For making this article, you need 2 hours. And you have the machine hours: 1 hour for A, 3 hours for B. We have also the direct material cost. So this is at the end for calculating the full cost. We have also the direct labor cost per hour. This is not per unit, this is the cost per hour. Then you have the overheads cost that you're gonna allocate. And so like here also again, we have always only one activity: the setup cost, the production, short-run variable costs, just as an extra, material handling. And you have these cost pools with all the same driver. Every time one driver: 20, 15, 7.7500, 18, total 61,600. And already in the given, you have the possible cost driver, but I think it's quite logic when you have the setup costs is the number of setups, because you know the number of setups. Production scheduling, you can say the number of production runs. For the short-run variable cost, you can take the labor hours, and for the material handling, you take also the number of production runs. You could have said also for material handling, we're gonna take the labor hours, or you can take the machine hours. So this is up to you what to choose, and I will not discuss your logic behind. I will only check whether the process afterwards is done in a good way. Okay, I would like to ask you that you take some time, like 10 minutes, 15 minutes to start up the exercise. At the end, the exercise is 100% the same with the exercise in the slides. So please try to work it out in your Excel sheets so that we can check it later together. But please work it out from the start to see that the different steps are understood. Okay, I give you 10 minutes. So the question is determine the total cost. Almost. That's very good. Almost, but need some more time. Great. That's really nice. Other people have come to the outcome. What is the total cost? Not halfway. We determine the total cost. Okay. Good. I give you a little bit more time. That's fine for me. Excel sheet, so then you have immediately already some evidence on this. So first of all, what is important? Everybody is there. Yes. Okay. Yes. Great. Okay. First of all, most of the time you have this as a given. Huh? Like you see, what is important, and I've hidden here this column. I will open it up. But this is a very important extra calculation you need to make. And so, like I said before in previous courses, also a labor, a wage, a salary, a labor cost, or is not the same as a labor cost per unit, or a labor hour is not the same as a labor hour per unit. So it's always very important that you calculate well with the right units. Right? So here in the given was a labor hour per unit, one. One labor hour per unit. So it's really key that you understand this well. Then we get to determine the total labor hours, meaning you have 10 products, 1 hour per unit, so there is 10 labor hours for product A. There is 20 products, 2 hours per product is 40 labor hours. So this is important. This can be also for machine hours. This can be for different things. So that you calculate this always in a good way. The same here. When you have €5 cost per hour in a euro, can somebody tell me what the direct labor cost is for one product of product A? And the labor cost is always the same. What is the direct labor cost of product A? What is the direct labor cost of product A? €50 for one product. This is the total, that's correct. For one product is €5. And because you need 1 hour for one unit, and 1 hour costs €5. And so it's €5 per unit is the labor cost. We're gonna make 10 units, so the total labor cost is 50. Is this clear? We can take another example. This is really important that you have this and that you always put behind your figures. That's always a good check. whether it is units, hours per units, dollars per units, meter per units, whatever, gallons, kilograms, whatever. Is it a dollar per unit? Is it a dollar per meter? This is very important that you indicate this always very well. Okay, here you have the different activities. Okay, we have 4 different activities. And we have the cost pools and with the cost drivers identified, like here. Total overhead is 61,600. So we should divide this 61,600 over product A, B, C, and D. Okay, the first step. So here, recognize the major activities in the organization. This is done. These 4. Determine the most appropriate cost driver. This is done. Number of setup, number of production, labor, number of production runs. So what you can do, we have not done it here. But it is possible that we do the production scheduling and the material handling, which is both on the production run. It should be possible to put it together also. It should be even more correct. We can work out like this. So when we see the cost driver and the rate, we're gonna divide the cost pool overhead cost dividing by the total volume of the setups in this case. So the total volume of the setup, so I have highlighted this also here. So what is important is that you calculate also the total always, and that you have always the totals. Then you know the number of total setup is 20. So you should divide this 20,000 setup costs over 20 setups. And these are the different setups. Okay. So it's clear 20,000 divided by 20 is 1,000 euro per setup. And so this is the allocation of the overheads. When you have 1 setup, it's 1,000 of the 20,000 you allocate. When you have 10 setups, it's 10,000 of the 20,000 you allocate. You do this the same for the production. The number of production runs is 31, like here. So you divide this by 31, and here you go the same. And so we have here 500, 15, 600 at the end. Then you go to step 5, putting everything together. So in the first place, you're gonna go with a direct material cost. Right? Direct material cost 200. How we come to that? So we can say that the direct material cost is 20 euro per unit. There is 20 and there is 10 units, so the direct total material cost is 200. Then we're going to calculate the direct labor costs. We say a labor cost is, like we just asked, it's 5 times 1 hour times 10 pieces. So this is 50. What you can see here. So the direct cost is already decided, it's 250. Then again, you will make the allocation. So it's a little bit the same as we see in absorption. How you're going to do this? You have a total setup cost of 20,000, and you're going to allocate it related with this ratio. So it's 1,000 per setup. So in the A article, there are 2 setups. So this means 2 times 1,000. In the product D, there are 8 setups. So meaning that we're going to allocate 8,000. What you see here. We're going to do this exactly the same always. And so here, production scheduling, we use this ratio, 500. So 500 times the number of production runs. 500 euro per production runs. How many production runs are there? There are 2 production runs. For product C, there are 6. So that's 6 times 500. Then you get a 3,000 here. You make the full calculation, like you've done before, with all the lines. you come to the total overhead. The total overhead is 61,600, and it equals again this one. Afterwards, you divide by the numbers produced, and in this way you can see what is the total cost per unit. So adding the direct costs and the overhead costs together, dividing by the number of pieces, and you have the total cost of your products. Okay, this is more or less the setup for all the art exercises. So is this clear? Are there Nadia, indeed, the major activities are always given. So I can make it more complicated to make like a business case. I've seen there is also a possibility that you work to a case, and then you get a one pager with a lot of information. What happens in a certain a real factory environment with a lot of information, so it's more like a case study. And then the idea is that you go then step by step by step. Okay, this should mean that this is more like an assignment to do, and you can work maybe quite long on this. So in our way of working with calculations, with Excel, with many exercises, this goes too wide, and I want to concentrate on, I should say, on the process as such. But this means also that you get, in most cases, a lot of indications already in the given. Okay, Ramesh. So a little bit the same answer. So I will. The activities will be very clear. The activities will be very clear because you will get this kind of information. So the possible cost driver, it's possible that I don't give this, but this will be also quite obvious, because you will have a limited number of information, and you get to use anyhow some information. When you say, okay, I'm gonna do the setup costs, then you have the number of setups. When you do the production scheduling, you have the number of production runs. Even when I should not give this possible cost driver, I think it's quite obvious for you to select one which is the most correct one. And even when you select another one, for me, this is not an error. But then you get to make your calculation in a logic way afterwards also. Okay, another question, Nadia, that's good. Just for curiosity, how these major activities are determined. Now, this is, we can go all back in the slides. So this is a little bit, the key point of activity-based costing, that we're gonna see in a whole production what kind of activities we are doing, and how much is a product consuming using these activities. So at the end, when you have a restaurant, when you have whatever company, you can very clearly see what kind of activities you are all doing, and every product will take a part of this, and to organize this activity, to organize the cooking, to organize the assembly, you have a lot of costs. Before we said, for instance, like rent or electricity, this is an overall overhead, water on the ground, and we try to put it inside. Now we're going to see that in the assembly, we have rent, we have electricity, we have a lot of different things, and we start from this total cost in the activity center, and then we're going to work. The reason we do it like this, okay, now we do only 2 or 3 or 4 activities, but in a full production site, you have many activities, and then it's much more secure. Imagine for a car, you have a car with a matte lacquer, so then he probably, and not a metallic lacquer, probably he didn't get to pass a certain a process, and then it means that they should also not, this activity is not consumed. You can have always some extra consumption of a product. When you go to the hairdresser and you want to color your hair, the coloring of your hair is a different activity than the cutting of your hair. And so then it's also logic that the costs which this activity incurs are all only related to the objects, the persons who use this activity. Is that clear? Okay. Is the setup of this question, because when you go to other exercises, I will go to exercise 6. This was the exercise of last year's exam. It's about genes. Okay, so at the end you see it's quite the same always. So here you have an Indian jeans factory manufactures 4 models of luxury trousers, fit, glitter, original and skinny. You have a little bit the same information, and I ask you at the end, okay, what is the cost of each trousers at the end, combining the direct costs and the overhead costs, which are here in this case 100,000 over, and you see again the same activities are put together. This can of course also a little bit be different. So it's and at the end the way of calculating in step 1, 2, 3 is also always the same. Right? So it is always the same setup. Okay. So you will see for this chapter, in fact, there is only one type of question. It's this one. And in exercise 2b, we will check this. So what is the exercises 2b? This is also the same look exercise, but here I ask you to make a comparison in between the previous method, the absorption cost, by working with a OAR, and compare it with the result of ABC. So with the information you have here, you can work out an absorption cost method, like in the previous chapter, and with the same information, you can calculate an ABC calculation. And then we will see at the end what is the difference in the result. Okay, so try to work it out. So you have both exercises you have done before, so it's possible to work it out. Okay. Any more questions on these exercises? Please go ahead. To A. What's your question with how do you do the short-term variable cost? How do you do the short cost? Short-term variable cost, step 5. Okay, we will take a look. So at the end, what we do here for the short-run variable cost. So this is just an information when you have a run which is shorter than foreseen. Okay, it's an expression in production. Then there is a certain overhead cost also to take into account, and this overhead cost is 17. Okay, so it's 7,005. Sophie, I come immediately to your question. So the short-run variable cost, we say this is 7,500, and we're going to use the labor hours as a possible cost driver. So this is the, so we should know very well from each product, A, B, C, D, how many labor hours we have. So we have calculated this. It's 10 times 1 per unit. And for the number of units, 10, 40, 50, 400. So in the total, there are 500 labor hours. When you do the rate, so you get to divide 7,500 by 500. So you see it in this line. Then you know that it is 15 euro per labor hour. Afterwards, you're gonna put it inside. So we come here on the short run. So what you do, you say 500 times 15 euro for a labor hour, and you have 10 labor hours. So 10 times 15 is 150. Here you had 500 labor hours. Oh, 400, sorry. 400 labor hours. So then you do 400 times 15. Is that clear? Okay, for question 3. So here again, here in my Excel sheet, it's a little bit different than yours, but okay, this is what I have calculated immediately. Normally you see it like this, huh? So at the end, can you repeat maybe? So the data are more or less the same, and maybe they are ordered a little bit differently, but at the end the data are pretty much the same. Okay, I have made already the totals, something what you should do normally yourself. I said this is what you will see, and you get more or less the same data. Units produced, direct labor hours per hour, per unit, machine hours, setup cost, orders, all this information. You have 3 activities with 3 cost drivers, and you will go exactly the same way of working. Is that clear for you, Sophie? Or do you need more explanation? Okay, any more questions? Please ask your question now, because that will help you probably to make the exercise at home in the assignment. So there are 8 exercises. Please really try to make all the exercises so that you can see. So at the end, the setup is always the same. The setup is always the same. Check your slides to see which steps you can do. Reach out and to each other. You can call whatever. Exchange your solutions so that we can check it also next week to control well that you see that you are on the end result. So it's really key. This exercise is quite okay. So everybody should end up with a real final information like we see here on exercise 1. Like we see that you come to the final information. To A. That you come to the final information that your product A costs 460, 465, 312, and 270. So you should come really to these correct figures. Yeah, for the videos, I will upload the videos. I will try to check tomorrow with a team from my team to check how I gotta do this, and then I will upload the video in I don't know, in Canvas probably. I don't know where to do it, but I will check it. That's good. Okay, I suggest that we leave it here for the exercise, that we're gonna end this class by some last information. So the appraisal, what's good, what can be better with activity-based costing. So you have of course a number of advantages which we have mentioned already before. So what is interesting is that when we go in a more complex production with many different activities, this is absolutely interesting because you can allocate a much more uh, how should I say, much more detailed cost to the right product who uses this cost. And you can see it in a hairdressers when you use a certain shampoo for a certain type of service, it should be only you who uses the cost of this shampoo. And this is maybe a direct cost, but also when there is something extra foreseen, yeah, then this should be only incurred the product who is really consuming the activity. That's very important. So this is a big advantage. Uh, okay, this is I think what is interesting also is that when you do this well, and thanks to the robust computer in the data management behind, this is absolutely possible. That also the management gets really very detailed information of how on a product A, B, C, D. So very often you have the case also like for these four trousers. Sometimes you are a little bit blinded by the number of sales or by maybe the volume you produce or sell, and that you don't look back how costly it is to make one article versus the other. So this is really key also to determine pricing and to check profitability. So so this is a quite good method, and it's widely used. You have of course also disadvantages, and yeah, these are yeah sometimes very important, and sometimes it's not very important. So this is a little bit to check what is on stake in your company. So so what is important is also that to do this on a company level, ABC, it will cost you a lot more than like a more simple cost method like absorption cost, or also what we're going to see later, marginal costing. So this is quite expensive, and but when you set it up, then it can be interesting anyhow. So check it out, these advantages and disadvantages, just to be complete. I should like to end this class to show a few more information. This is there will be no exercise on the exam of this part, but it's anyhow interesting. And at the end, probably it's one of the most interesting ways of making cost calculations. And I want to give this as an extra, just food for thought, and to see. So these guys again, Mr. Kaplan and Anderson, they have developed a one step further ABC costing, activity based costing, which is called time driven activity based costing. And so the time driven activity based costing, at the end, what they're gonna do, they bring back every cost to a time. And so every cost is brought back to a time. So to 1 minute. When you use, like for a lawyer, when you use 1 minute of a lawyer's time, how much is the cost of 1 minute? When I use it 5 minutes, I pay X time 5 minutes. When I use it 25 minutes, I pay X time. So this is a system which works pretty simple because at the end there is only one uh, relative component, which is the time, and this is quite easy, like quite easy. That's not true. Relatively easily to determine. So they will use always in this method the time as a distribution key, as the reallocation of the indirect cost. We speak again about indirect cost. So we can see here that it's always the number of time units consumed by an activity. And so these are the two parameters you get to know. And so when you say the cost for 1 minute for a lawyer, for a hairdresser is X euros, and to do this activity, I need X minutes. I do the cost per minute times the minutes, and I know the cost of the overhead. So this is quite interesting, and the only thing which is sometimes difficult is to determine all these times. But I can tell you that in many organizations there are many cost calculators who are working with the stopwatch to really time what every activity takes. And this goes in seconds. So to check this out very well. I give you an example, just an example of which can happen in a service organization, back office, where they treat orders. And just to explain the example, so you have an office where they are working as 6 people, and these 6 people they cost for the business 5,000 euro each. So the total cost of this office is 30,000 euros. So then we're gonna calculate how many minutes that these 6 people work in 1 month. So we're gonna calculate because the salary I have said is also for a month. So they work 22 days. They work from 8:30 to 15 to 1700 hours. They have a lunch break. This results in 8 hours a day. They work 22 days, so they have 1056 hours that they work. So this means 63,360 minutes they work. All this thing together works 63,360 minutes. Then most of the time they put the effectiveness ratio because of course these people don't work effectively on a job the full day. They have a toilet break, they have maybe a coffee break, they chat a little bit with colleagues, they make a call or whatever, which has nothing to do with the job. So we set it here on 79% just for the sake of the exercise. So this means that there is a monthly effective capacity in minutes of 50,000. There are 50,000 minutes available, and the total cost is 30,000. So this means that every minute of capacity costs 0.6 euro per minute. Is this clear? Is this clear for all of you? It's a very simple calculation. So it's a 0.6 euro per minute. So it's 50,000 minutes, which is the capacity. When you calculate all the time these people have to work on a job, and then you say the total cost is 30,000. So then 30,000 divided by 50,000 is 0.60. And you go one step further. Now you're going to see the activities and you're going to calculate how much time every job costs. So we have here an example. So when there is a normal order, it takes 5 minutes. For every extra order line, it takes 2 more minutes. When there is a phone order, it's 15 more minutes. Right? So you can say in the order processing as an activity, the processing time is a calculation which is 5 minutes per order plus 2 minutes times the number of order lines plus 15 minutes times the phone orders. At the end, you have a certain number of minutes you need, and that you can can calculate times the 0.16 euro per minute. For the packaging and shipment, you do the same. A standard shipment takes 25 minutes of these people. A sea freight is a little bit more job, and a special packaging is also a little bit more job. When you go one step further, you see here the data for customer 1, customer 2, customer 3, and you can see what they do in a certain period. So customer 1 is doing 100 orders, 50 phone orders, 8 order lines per order. They do 20 shipments, 10 air sea shipments, and 0 special packaging. So we see that the turnover, this is just an extra given, but then we're going to see what is the order processing. And this figure, you're going to calculate by using these numbers and evaluating him in the equation you have here times the 0.6 euro per minute. So at the end, it's a 3-step level calculation, and you can come in this way to the perfect allocation of your overhead costs, which is in this case 20. It's this together. So, and then you can see also that for some products who seem to be quite a good sales margin, at the end, in the profit wise, it's totally not the case. Also, because you spend much more time to customer C, they have more shipments, they have more orders, they have a lot more, but the turnover is relatively weak. Okay, is this clear for you? Okay, this is just to make this course and this chapter complete. So we will concentrate our exercise on the standard ABC, but this is anyhow a nice. I will send you a small exercise also in the canvas just to check it out. It's anyhow a nice exercise to do and to work purely on the minutes. Purely on the minutes, and this is how a lot of people work. When I see audit companies, lawyer companies, bookkeeping companies, they really measure the time on everything they do. And of course, some activities have I should say actual times, which is an average, and which they use. But this is really an interesting method, and it's quite good. Of course, it's quite time consuming to do this because you get to calculate all the time how much time, or you get to measure this how much time you use to do a certain activity. Okay, good. Any more questions for the lecture of today, for the course of today about activity-based costing? Can you put on your camera again and I can see you once more? And when you have questions in it, I've written your mail. Was my answer okay for you?
Yes, it was okay.
Okay, I think it's key when you don't understand, please stop me, ask to other people, and because there is absolutely no issue to go over and over again to the questions until you really understand it. Okay? Good. Other questions? Okay. No more questions? It is already dark on your side. Okay, then I would like to thank everybody for your attention and your cooperation, and we see each other next week. I will upload the assignment also. Please make the exercises, all of them. And we will start next class with the correction of the exercise. And then we go in the third method of cost calculation, which will be the marginal costing function, where we will see a very thin calculation. Okay, I wish you all the best and have a nice evening and a good week, and we see each other back next Wednesday. Ciao.